Hello, everybody, and welcome to the final presentation session of the 2020 CERN Webfest. Thank you very much for joining us.
Hello, and also welcome from my side. This is indeed a very special session, a very special webcasting, because we've reached the end of hacking. The hard weekend, the intense weekend, but hopefully also the fun weekend is over. And we are very excited, our dear participants, to see what you've been up to, what have you achieved, what have you managed to do. Very excited about that, and a very warm welcome.
Yes, thank you very much to each and every one of you for all of your hard work over the last 48 hours. So it's exactly 48 hours since we kicked the hackathon off. We really appreciate you sending in all of your submissions. And over the last hour, all of the team here have been working frantically to compile them. And over the next hour or so, we're going to present them all to you. Many of them are going to be completely fresh for us too. So we cannot wait to see what you've been working on.
Indeed, yes. Before, however, we are going to jump into the final presentations, we would like to remind you, dear participants, to always use the CERN hashtag while posting any updates regarding Webfest 2020 on social media. Please don't forget to use the CERN Webfest hashtag while doing any posts regarding Webfest 2020.
Yes, that's right, Anastasiia. So you can see the hashtag now on your screens. Please, by all means, do talk about the Webfest. Tell your friends to come and join. Let's all take a look at what what you've been working on over this exciting weekend. So let's move on to the next slide, please. So yes, thanks again to everyone, and if we could move on as well to thank our mentors, of course. So we've had, as well as the organizational team and the people helping out on Mattermost answering questions. We've also had a fantastic team of mentors over the last 48 hours who have kindly volunteered their time to provide guidance and act as a sounding board for all of you working on the Webfest projects. So thank you from all of us at CERN Open Lab. Thank you from all of us in the CERN Webfest team to each and every one of our mentors.
Thank you. Yes, should we jump straight into the final presentations video? Andrew, I'm very excited to see the outcome.
Yes, exactly. Yes, let's not wait any longer. Let's get started then. So just to be clear, we have about 30 submissions in the end, and we have separated these by topic, as we did on Friday with our introductory session. So we're going to start with a project idea called CERN. So we would like to now show you the video submission about this project. Well, thank you very much indeed. That looks fantastic. With this project and with all, of course, we understand that 1 minute is a short time for a video. So do not worry, all information will be available on our website very shortly, and you'll be able to browse the projects at your leisure. So we're now moving on to take a look at the second project under the topic of science communication. And that, I believe, is the online science show.
Our team of spies was captured on a secret mission. Now they must use science to escape. Can you help? In this online science adventure, we use the group intelligence of the audience to guide our spies to escape from their captivity. The live feed of our spies is streamed directly to your screens, and you call the shots. The interactive questions in Pear Deck enable anyone aged 8 and up to vote on which experiments to perform, how to perform them, and what to explore next. Your votes will determine the course of the mission. Each experiment will lead you closer to success. All spies are trained for the experiments before the mission, and you can follow along by looking at their case files. Across the adventure, you will get additional information on each topic directly from the headquarters. All the experiments are easy to replicate from home, so all you need to participate is an internet connection and a passion for discovery. If you only get one shot, can you choose the right path to saving science, or will it just blow up in your face?
Well, fantastic. Thank you very much indeed for that. Who needs James Bond films, eh, when we've got this? That's great. So that was the second of our science communication projects submitted here on the slide. You'll be able to see the number of participants. All of these numbers are somewhat inexact because things obviously have changed over the weekend, but it gives you a good idea, at least of the number of people working on each project. And also we have team numbers just for information. This maybe helps people that have been at the Webfest get in touch with one another to follow up. But as I said earlier, all information will of course be available on our website very soon. So next we'd like to go to a project called Webfest. These are the experts you are looking for. An excellent Star Wars reference there. So let's cut over to that project video straight away.
Hashtag Webfest. These are the experts you are looking for. Maria is a researcher. She is analyzing data to search for new physics. She's looking for another expert to improve her method. Due to the large group of experts and the lack of specific information, she cannot find the expert she is looking for. This is us. We created a tool to guide you through the expertise at CERN. Each expert is tagged by keywords extracted from talks stored at Indico. The relation between experts and keywords is represented in an interactive network. This is our network. Maria can find the expert she was looking for and even more than that. The gets an overview of the research done at CERN, find new inspiring topics and meet new collaborators. She will recommend it to other organizations with huge networks of expertise that wait to be explored.
Great. So thank you for another excellent video there. For those following who are not familiar with CERN, there was a reference there to a tool called Indico. So just for everyone to be aware, Indico is a software platform developed at CERN that is used for event organization. And it's now used by a number of other large organizations. So in the video that you just watched, where there's a reference to Indico, it's where we use to organize all of our events, such as this one, but also workshops, daily meetings, symposiums, so on and so forth. So there's a lot of excellent information available in there. And the team are very right about finding ways to capitalize on that. So maybe we could now move to the next slide. We have some more science communication topics, two more projects here. As you can see, science communication was a very popular topic, and it's a subject close to my own heart as a science communicator, as is Anastasiia, my co-moderator. So we're now going to move on to the next project, which is called Practical Physics Made Easy.
Welcome to the first day of astronaut training camp.
Well, fantastic. As some of you have been following the Webfest schedule closely will know, we actually have at 8 p.m. CEST tonight a DJ session. But had we known we had a ukulele extraordinaire, we could have invited him along instead. Thanks very much for that video. That was great. And now to the last of the science. And we're now moving to the last of the science communication topics, which is machine learning. How does it work?
Good afternoon, my name is Aitor, part of Team 47, tackling the challenge machine learning, how does it work? The idea behind this topic is to build a 2-3 minutes interactive and dynamic game to be showcased in the exhibition part of the new building Science Gateway at CERN in Geneva. We started by drawing some diagrams and depicting the different scenarios on how the user interface would look like. We also gathered some information here on the right, as you can see, and we had to narrow down and digest the theory behind machine learning so as to provide it as easy as possible for the visitors. We thought about doing this by defining a character, Mr. Apprentice, and then creating different scenarios for the game, and by means of clicking the buttons, answering the questions, and interacting with the pictures, you will gather that knowledge from machine learning. We started with a sandbox playground game to get familiarized with Python arcade library, and then we created a prototype which is still not finished, which is this one over here, even with music, types as algorithm. You can go back, more data, better learner, and this is how does it look right now. Wishing you all the best, have a good evening, take care, cheers.
Well, thank you very much indeed. So that's the last of our 5 projects on the topic of science communication. So I'm now going to pass over to Anastasiia.
Thank you, Andrew. And yes, we are now moving to our second category, which was facilitating research. Another important topic, especially in the context of this year's Webfest theme, which was working together about accelerating collaboration, where the main idea was to help find solutions for remote collaboration with scientists and to support the scientific collaboration after it has been so dramatically changed because of the global COVID-19 crisis. So let's begin with our first video. I'm really excited about it. So the first project under this category was quizzes, constructing collaboration. The team had 10 participants and it was team number 9 working on this project. So please, let's see the first video.
Kios is a web-based application with the goal of creating connections between people in academia, from undergraduates looking for professors to work for, to for veterans of academia seeking out collaborators on specific research topics. Kios's purpose is to act as a search engine for information logged in a database about faculty and academic professions in universities around the world. There are 2 parts of the website scraper and the database. The website scraper looks up the universities on the Wikipedia to find their websites. Then it searches through the faculty pages and uses a neural network to extract the professors' names from their websites. Finally, it looks up these professors on Google Scholar to obtain statistics such as their citation rate. The scrap data from the CSV file is fed into an SQL server which manages and organizes the data based on a user inquiry. A user fills out the necessary fields on an HTML form, which submits the search terms onto a Google Sheet. This is read off by another Python script, which uses the research queries to execute different SQL queries depending on the search terms. The SQL queries return HTML table data, which is displayed to the user. All of our results can be.
Well, thank you. That was really a quick overview. We, of course, understand the participants that it is really hard for you to somehow summarize in just 1-minute video the whole work you've been doing over the weekend. But thank you for doing it great. You really managed to explain properly your project in just 1-minute video. And I'm very excited about the second one. So let's go ahead. Thank you so much. This was the video from the team number 27, Less Typing, More Thinking. This team had 16 participants, and thank you for your great video. Again, very precise and brief, and with a nice music. I'm happy you guys kept so optimistic and positive. We feel the energy. Thank you. Another video, the set one, in the is studying abstract mathematical structures using data, ML, and AI. So let's go ahead. Team number 26 with just one participant. Let's see the video.
Hi everyone, so let's get started. The idea about this project was to be able to detect substructures within a list and to be able to tell whether two lists have the same substructure. The potential uses could be to cut down duplicates in data processing. I started with a brute force comparison algorithm which was not able to detect any substructure in an ordinary data. Then I trained a logistic regression model on the substructure of the first list to predict a substructure on the second list, but the model just memorized the substructure of the first list. So I started implementing providing multiple arrays to train the model instead of one, which I did, but I have not completed providing multiple arrays as input for prediction. The exciting thing about this project is that it allows one to define abstract mathematical structures without explicit definition. This algorithm is not very efficient, but I think of this as more of a way of thinking than one single problem. Thank you very much.
Thank you very much too. We can imagine that it was a little bit harder for you to work alone, but you did a great job, a great video. Thank you so much for this. So, and we can move to the next slide. As you see, we still have 3 projects under the facilitated research category, and our another team, team number 31, has been working on a challenge theory of 3 folds and 4-dimensional universe. 3 participants have been working on this challenge, and I'm very excited to see the video.
Just to come in there, Anastasiia, I believe there's not a video for this particular project, unfortunately. Okay. However, this is a good opportunity to reiterate that all of the projects will be available in the coming 24 hours on our website. So please do browse them at your leisure there, even those for which you've seen the video, of course.
Okay, good. Thank you, Andrew. So let's then move to the second team, team number 22, with the 4 participants, and they've been working on the challenge Labyrinth.
Hypothesis that you want to test, or do you have experimental equipment that you don't use? We introduce Labyrinth. With Labyrinth, you can bring any lab onto your computer. You can share laboratory equipment with your colleagues. Join the global network of scientists and researchers. It's as simple as logging onto our webpage and seeing available equipment. Go to equipments that you like and see their technical details. If you like them, go to their rent page and get them for free or for a fee. Here is an example of a remotely controlled car that can go around the room and measure the temperature.
Thank you so much. Thank you, team number 22, for your video. And I believe we have the last submission in the category Facilitating Research, which is CERN, Urban Solution for People, team number 5, with 5 participants on board. So let's dive into it. Thank you so much, team number 5. Andrew, each time I see a video we've got submitted, I get a feeling that you cannot be even more creative. But then another video comes, and I understand, okay, this is even greater. So I'm really impressed, really, with all the submissions and the work you've managed to do, dear participants. I think we can move on to our next category, which is data visualization, I believe.
Great, you're right, Anastasiia. I completely agree. We're very impressed by the videos you submitted. As Anastasiia mentions, the next category is data visualization. And this, again, is a very important topic that cuts across a number of others, whether it's facilitating research, communicating science, education. Data visualization is key across all of these areas and across fields of scientific research, of course. So I would now like to pass you on to the video from Physics Concept Mind Map.
Hello, everybody. For our Webfest 2020 project, we decided to make physical concepts using mind maps. We decided to use mind maps because of the way that the person thinks. We think in branches, not in a straight line. Whenever we think of a concept, that concept can be broken down in several parts, and those parts can be broken down even in more smaller parts. So the goal is to create a website filled with several different mind maps and help learning. This is our website. For example, now that we click here, we have a classical mechanics mind map. And for example, the person wants to learn more about force. They can click there. It contains a small definition, videos, a brief introductions, and related topics.
Excellent, thank you very much. Continuing now with the topic of data visualization, we move on to the Virtual Web Museum, which is another small team, in this case, just 2 participants, but we can't wait to see what you've been working on.
Disclaimer, the following video involves wearing VR goggles outdoors and was performed with the necessary precautionary measures to avoid any injuries. We have developed the UI such that this could be enjoyed just as much from the comfort of your chair or couch. Discretion is advised.
Great, thanks very much indeed for that. As many of you who are watching will know, CERN is indeed the birthplace of the World Wide Web. So it's particularly nice to see things coming full circle and seeing a proposal for a web museum here at our Webfest. So as you may have heard then, we are now moving on to the next project, which is called VisuPy, and was developed by a team of 4 participants.
Hello, and welcome to VisuPy. VisuPy is an easy-to-use code visualization tool, which converts Python code into an easy-to-follow flowchart. Quite often, raw code can be confusing to look at, and hard to understand the function. However, flowcharts present a simple alternative, which is much more intuitive. This is where VisuPy comes in. VisuPy takes input code and converts it into a flowchart drawn in LaTeX. It scans through the input code and works out the function of each line before setting each line up as its own box in the flowchart. With a simple Python command to specify the input function, a flowchart is quickly rendered and output as a text file and PDF. The LaTeX output makes maths and physics students an ideal target for VisuPy. As well as allowing them to better understand complex algorithms, they could also use it to quickly generate flowcharts for code which they want to embed in their own papers, so their reader can grasp a better understanding. Thank you for listening. VisuPy, visualizing code flow made easy.
Great, another excellent video there. And I believe we may have one more video. I think that the topic is latex to speech. I think our stage managers will confirm in my earpiece if that's not the case, but otherwise, if there is another video, which I think there is, please do roll it. Okay, so this is another VisuPy project. So these are two teams that have worked on similar projects. So please let's roll this video too.
Welcome to PodPaper, the software that turns your academic papers and photos into an interactive podcast. The goal of this project is to relieve strain from academic work. Whether you're staring at screens too many hours in a day or feeling disconnected from the papers you read, we think we have a solution for you. It works like this. You pass your PDF to a parsing convolutional neural network that decides where to send your data to reconstruct a LaTeX document. That LaTeX document is then used to create a decision tree and an interactive text file through a text-to-speech engine that you can browse to and fro through your document with. Over the weekend, we built a primitive text-to-speech engine for mathematical equations and a primitive decision tree generator. We also built a dataset for training a convolutional neural network, but we did not train it. We struggled implementing an open-source PNG to LaTeX math system, but we did implement an open-source PNG to LaTeX text system. We also built a front-end web-based UI for PDF, loading PDF, and listening. Moving forward, we need to build bridges between modules, create a more varied training data for the AI, and vastly improve the support for LaTeX symbols. We also used PyTorch, PyText-to-Speech 3, and Image2Markup, as well as PyTesseract as open-source libraries. Thank you.
So thank you very much for that. Just to be clear, apologies for the mix-up beforehand. So these are two projects that stemmed from the initial idea, VisuPy, and this second project is not called latex to speech, as mentioned on there. So there are the two projects. There's latex to speech, and there's the PodPaper project, which came out of the VisuPy idea. So thank you very much to both of the teams for those. It's really interesting to see, of course, over the space of a weekend, how these things develop. And we do always, encourage people to follow their creativity wherever it takes them. So it's really nice to see two similar things develop in completely different ways. Thank you very much again to both of the teams for those videos and for all of their hard work over the weekend. So we're now going to pass on to the next topic. So over to you, Anastasiia.
Thank you, Andrew. And yes, we are moving to another topic, which is health. I mean, it goes without saying that this topic is one of the most urgent now in the current circumstances we are now all facing, unfortunately. And we are very happy that we had a lot of challenges and a lot of people were addressing exactly this topic. So I'm very excited about the outcome. And let's jump into the first video from the team number 23, consisting of 2 participants with the challenge patients in-house tests and plans of stay in ICU. Okay, so I just received a message that unfortunately we do not have a video submitted from this team. So let's move to the team number 39, consisting of 8 participants, and the team has been working on the challenge design of a LINAC for breast cancer treatment.
Days passes by, and most long for a place that they never find. I'm afraid I wake up when I die, and it is too late to climb any mountain. Time is of the essence, the blood
Thank you so much for the video and for your work on this important issue and topic, team number 39. I have to confess, I remember your idea submission and the great description you had and the great idea in the background. Thank you so much for not being indifferent to such a great issue as breast cancer. And thank you so much for taking this challenge and working on it over the whole weekend. Very much appreciated. And now we're moving on to another team, team number 6, and their video submission. Team named Detox EX, Fighting Depression with Advanced AI and ML, consisting of 4 participants. Very excited about your 1-minute video.
Hello. When you're sad and depressed, scrolling randomly in social platforms, what if your phone starts suggesting the best choices for you? Our smart algorithms can suggest you the best music according to your mood. Or a good movie, a brilliant book, a thrilling piece of art. The algorithms might show an upcoming opportunity for you too. .orx got to know about CERN Webfest from Twitter. Our experts are making a huge database of positive, inspiring and useful contents that will be silently presented on your social media according to your preference. The AI will also filter harmful contents if you wish. You just need to install an app on your device. That's it. And thanks to our programmers, we will be open sourced for the betterment of humanity. Thank you. Stay safe and smile.
Thank you so much for such a great idea and a great work. Indeed, depression is another great challenge, especially it has been during the last 3 months, in the time of the COVID-19 crisis, a very urgent topic. And thank you so much for this idea, for this great job you've done, team number 6. And I believe we have one more video in the category health from team number 38, consisting of 4 participants. As they've been working on a challenge, ECG database for patients with COVID-19 symptoms.
Sorry to come in here again. I'm seeing some information from our kind stage managers who are telling us that we actually do have one more project under the category of health, but it's not a submission marked on the slide. Instead, it's a project called Help Acceleration from team number 45, and I believe we do have a video for that. If so, perhaps we could roll it.
Hello guys, this is Sina from team 38. Let's walk you through EKG database for COVID-19. As you can see, this is our basic workflow. We take an EKG image, we put it to a segmentation process, and then a digitalization part, which is run by some OCR detectors, and the final output is going to be fed to a database. So this is a EKG datasheet. It's graded. We're going to noise cancel it and get rid of the graded in the background, then dedicate a different color for each signal, and then run some object detections on it. And what we get is 12 different signals. As you can see, this is a binary image of it. Then we're going to run some OCR detection on it and create a digital image exactly like this. For each data point, there's a T and there's a voltage. And this is our goal. So at the end, we're going to design a UI user interface for our website. As you can see, this is a template. We have created an emergency kit for COVID-19. And basically, this is the whole idea. I hope a great run for everyone. Thank you very much. Peace.
So, sorry, just to come in there again with a small clarification. Apologies for the confusion just earlier when I jumped in to introduce that video. We're getting some new information from our stage management team, and it turns out there are actually both projects. So, of course, as you just saw, there's the ECG project, and then there's another project that Anastasiia is going to pass over to now from team 45.
Exactly. As far as I believe it's the challenge the team 45 has been working on is help acceleration. We're excited to see the outcome.
Good day, everybody, and welcome to iHelp Acceleration website. So the website consists of a game. Here's more about the game and the rules. This is our team, and also consists of a forum where we can discuss different type of learning topics, such as how to beat the virus, for example, or studentships, and you can also rate the website. So let's take a quick shot review to the game. Okay, so the game is basically about taking care of 3 different types of trees, and each one will teach you a very important lesson. So everyone should play this. This is a must-play game. So a little example. Let's do with apple tree, because this was the tree that hit Newton's head with an apple. So you'll learn a lot of this one. Got it? And this is our seed. Learn. So you have a lecture, take a quiz, A, and you make your tree grow. And each tree has a different task and different everything. So you should try it.
A lot to go through, which is fantastic and is testament to you all and all of your hard work. Thanks again for participating over the weekend. We do ask for your understanding when it comes to our organization of the projects, because we received your submissions and your videos just under an hour ago, and we have been working frantically to put this all together. So apologies for any confusion at any point, but we think we have a handle on top of a handle on everything, and we know which projects have and haven't been submitted. Of course, if anything's missing, our kind stage managers will let us know, and we will cut to those videos too, even if they're not mentioned on the slides. So to continue, volunteer computing. First of all, we have a project called Hello Friend from Team 43 with 7 participants. Let's roll the video.
Hey everyone. So when we thought of the theme, working together apart, our first question was, how do we find other people to collaborate with? This is what inspired Hello Friend, a streamlined platform for programmers to find like-minded individuals to work together on innovative new projects. Here we can like or dislike other projects we're interested in. These are all posted by other programmers from all around the world. But first, let's make our own project. I have a cool new idea I want to try out. Okay, so I might use this in next year's Webfest, so no stealing. And, languages. Yeah, I think we're definitely gonna have to go with Scratch. So I can edit or see my own projects, and I can check out the other projects that I've previously shown interest with. Oh hey, I have a message from someone who's interested in my project. Hey Barry, looking forward to working with you. Thanks to all at CERN for organizing the Webfest. And thanks for watching.
Great, thanks for that excellent video. And I'm pleased to let you know we have another one under volunteer computing, which is a project called CERN Space, and it's from a team with 8 participants.
With many researchers unable to attend their labs due to the pandemic, many experiments have been conducted through simulations, which are often costly and highly intense to compute on a single machine. Our platform, CERN Space, pairs research projects with volunteers, who are willing to help researchers, by donating computing power. Upon completing our quick and easy setup, volunteers are ready to help researchers on their projects, and share their computational resources, to maximize researchers' abilities to produce results. Since our technologies are built on the Docker Swarm platform, it's easier than ever for researchers to conduct experiments and perform simulations. The only constraint is that they have to build their programs to run on a Docker stack. We made this project because the pandemic has been a difficult time for all of us, and we wanted to ensure that we, as a society, are still moving the needle forward and continuing to innovate. Because that's what really matters. Flexibility is of utmost importance for the longevity of CERN space. Even when we are able to meet people after the pandemic, CERN space will still be relevant to projects by giving more people the resources to carry out complex tasks. Thank you for watching.
And that's all for volunteer computing. So I'm now going to hand back over to Anastasiia to go through the next topic, which is education.
Thank you, Andrew. Yes, indeed, we are now moving to education, and I'm really happy to mention that we had so many great ideas under this category. So many people are working on it. Really, another very important topic and issue that has been drastically influenced by the COVID-19 crisis. And we are very excited about all your ideas and tools you've developed to help support remote education and online education under these special circumstances. We are going to start with second video, internship opportunities in Latin America, as unfortunately we don't have any submission from the team number 42. Delve right into it, sorry. So we will go dive into the second project, the team from team number 32 with 2 participants with the challenge internship opportunities in Latin America.
During the pandemic, hundreds of academic opportunities have migrated towards digitalization. Duke is a mobile application that centralizes and displays these opportunities for students to apply. During the weekend, we focused on building the functionality of the mobile application. The user is able to scroll through real opportunities and visualize their type and category through a tag system. The user is able to open a specific opportunity, for example, an entrepreneurship competition, and add it to favorites in order to receive notifications and reminders. The user can then directly apply to the opportunity. A user ability map is implemented with Watson IBM machine learning services. This map analyzes the user profile information, which is hosted online in Firebase, to recognize the abilities that the student wants to acquire and the opportunities that can help them develop those abilities.
Thank you so much. And I've just received a message again from our stage coordinator that the team 32 actually, who has just presented this video, was renamed to Doc. That was probably also obvious from the video, as they mentioned their new name in the video. So thank you so much. We're moving on to another video in the category education, which is from the team number 4 with 7 participants. And the challenge they have been working on is next generation learning management system. Let's dive into it. Thank you so much. This was a great presentation. Thank you so much, team number 4, and for your video. A great idea, great project. And now we are moving on to another video in the category education. Online science hands-on was a challenge, and the team that has been working on it was team number 34 with 6 participants on board. Very excited about this one, as I also remember that this idea when it was just submitted. Very excited about the video you prepared, guys.
Now, more than ever, the youth needs inspiration. Many outreach programs offered by CERN for pupils are comprised of hands-on activities which had to be cancelled due to the ongoing pandemic. If this crisis continues for a long time, this needs to adapt to social distancing. We therefore propose to build a website to provide easy access to hands-on activities, a platform that can easily connect schools to CERN scientists and provide additional expertise and the feeling of meeting a real scientist. A set of simple experiments is provided that can be done with common household items. We offer the possibility to book an online guided session together with one of our scientists via an easy-to-complete booking page. Why not do the experiments together with a scientist who can help you and tell you more about how it is working as a scientist? We're interested in providing you with the best experience possible and share the spirit of CERN with you. And all of this free of charge. See you in the classroom.
Thank you so much. I mean, I'm always so excited to see how far creative people can be and how much effort and work they can do, and all these great videos you've made just over a weekend and probably even less in a couple of hours. This is really great, guys. Impressed with your creativity. Thank you so much. We had two more teams that have been working on challenges in the education categories, but unfortunately we do not have any videos submitted from them. Anyway, I will mention these teams. You can see them also on the slides. This was the team number 28 with one participant that has been working on the challenge The Detector Is You, and the second team, team number 37 with two participants on board, has been working on challenge Which Particle Accelerator Fits Your Interest Profile Best. As mentioned before, unfortunately no videos submitted from these two teams, so we are moving on to our last category. Andrew, I hand over to you.
Thanks, Anastasiia. So our last category is sort of a catch-all for things that were not submitted within the other categories. Just to remind everyone, these are the categories that that you, the Webfest participants, have selected when uploading things. So thank you for doing that, and let's go straight into these then. I understand that of the topics shown on this slide, there is actually only one where we have a video, and that is indeed the last one shown on the slide, 9 Quantums Morris. So I'm very happy to hand over to the video now, which will roll in just a few seconds.
Hello, everyone. Our team focused on the 9 Quantum Morris challenge. Our team was quite big, but together we explored how to make an AI that can play the 9 men's Morris game, and we tried to do this using quantum machine learning techniques. The 9 men Morris game is a 2-player strategy game that's been around for thousands of years, with the goal of trying to reduce your enemy's pieces down to 2 in 3 phases. In phase 1, you try to place down pieces into either a 3x3 long row or column called a mill, in which case you can remove an enemy piece. In phase 2, you can move all your positions around, and in phase 3, you fly if you're down into 3 pieces. Our first main challenge, however, was to get the previous code that we worked off of to work, because it wasn't working fully. After we fixed the code so that it works to our satisfaction, we explored 2 different avenues using quantum computing and quantum machine learning with QuizKit. Our main excitement was with the quantum machine learning because we wanted to explore how qubits could be added into hidden layers in PyTorch. And while we trained a couple of networks, we didn't get any good results, but it is actually quite exciting that we're getting any results at all. So we have to explore this further.
Also explored the D-Wave part of this project, working with real machines and simulations, and we also explored the difference in their gameplay, which was quite interesting. We used different samplers in hybrid and quantum to observe the difference in the first move the AI makes, and how it has an impact on the energy levels of the following moves. And while we didn't have a result of substance, it is quite interesting to explore, and we plan to progress this in the future.
So thanks for watching. I hope you enjoyed. It was really fun to collaborate across time zones and across nations over the internet. I thought it was quite enjoyable. What about you?
Yeah, it is quite coincidental, because that's also the theme of this year's Webfest, working together from afar, which we really enjoyed, and we basically saw that science and exploration knows no bounds.
Thanks for watching.
coincidence, I think.
Okay, so thanks again for that video. I believe that one might have run over a little bit, but don't worry, we won't hold it against you. It was very appropriate. There were 9 of you, sorry, there were 15 of you in that team, and I understand that this was a project that started at last year's Webfest, or if it didn't start at last year's Webfest, it was certainly developed partially within last year's in-person Webfest. So I'd just like to say again how fantastic it is to see people come back from one year to the next, which of course wouldn't be possible were this event not online. And we are very keen to hear more from you and all other participants about how you have felt this event has worked as an online event versus an in-person event. And perhaps there's opportunities to do similar things again in the future. So speaking of online versus in-person events, I'd like to go to the next slide, and you will see there the final idea or challenge, which was to create some kind of application to calculate the difference in CO2 emissions between online and in-person events. And here there is just one team shown, Team 48, with 9 participants, but I understand that actually 2 teams have worked on this. I believe the other one was Team 7. So we're going to show you both of these videos one after another. So first of all, we have Team 48 with 9 participants, and then Team 7 with 4 participants. So perhaps we could show the 2 videos back to back, given they're addressing the same challenge, please.
Because of coronavirus pandemic, all scientific conferences, summer schools and internships were cancelled or moved online. This fact has disappointed hundreds of people all over the world. But can we find any advantages in such situation? Have you ever thought about the amount of carbon emission we produce while traveling to scientific conference? We guess you haven't.
We created a website with an online versus offline event CO2 emissions calculator. So you can select here your starting position, for example Moscow, and your end position, for example CERN, Geneva. And you can select your type of transport, for example plane, and the duration of your stay there. And you can calculate your CO2 emissions by in-person meeting and the emissions that would be produced if your meeting is online. So you can understand how much CO2, how less CO2 you have produced.
Okay, so that was the first of the 2 videos. For those who have actually been taking part in the Webfest and that are watching this and who have been paying close attention to the team numbers, just to be clear, that was actually the video from team number 7. The video that's about to start now is the one from team 48.
Greetings everyone. We are proud to present our solution for the challenge video conference versus in-person CO2 calculator. Have you guys ever wondered how much CO2 the online meetings emit? Have you guys ever wondered will that CO2 cause any damage at all? We present the analysis of the total cost of video conferencing, including operating cost of the network and video conferencing equipments, life cycle assessment of equipment cost, and the time cost of people involved in meetings. Well, we have created a Python program taking the details of an online meeting as input and producing the resulting CO2 as an output. Example input may be a 2-hour long call presenting using sound systems, 3 microphones, cameras, using 4 desktops, all with LED, LCD displays, 3 laptops, 2 plasma display screens, and this was the result we got. While the cost of these meeting forms depend on many factors such as distance traveled, meeting duration, and the technologies we used, we find that video conferencing takes at most 7% of the energy of an in-person meeting.
Okay, so thanks very much for having watched all of those videos with us. That was the last of them. As mentioned before, all of the information will be made available on our website. We're working as quickly as possible to get that on there. So don't worry, you'll be able to browse all of the projects at your leisure. And thank you again for your patience. It was a real challenge to get all of this together in the space of an hour between the submission and the start of this presentation. So I'd also just like to express our heartfelt thanks on behalf of Anastasiia and I to all of the rest of the team.
Indeed. Thank you so much. It was a great work. I think we can now move on to another very important part of this webcasting, and namely, we would like to show you again and present you again our dear judges who are going to evaluate you, our dear participants, and your project. We're now going to show you a list of them on a slide. So, Alessandra Rojas is a Sustainable Entrepreneurship Manager at EPFL. Ben Siegel, whom I suppose you all know, he's a co-founder of Webfest and an honorary staff at CERN. Bilge Demirkos is from Middle East Technical University, and she's a professor of high-energy physics. Caterina Doglioni is a senior lecturer at Lund University. Charlotte Varaka-Ulle, Director for International Relations at CERN. Charlotte, we are very, very honored to have you on board. Thank you so much for being us this time. David Galbraith, designer and serial entrepreneur at Anastasiia Group. Francois Gray, I guess no introduction is needed here, also co-founder of CERN Webfest and director of the Geneva Tsinghua Initiative at the University of Geneva. Ines Knepper, one of our mentors as well, and a judge, obviously. She's Innovation and Hackathon Lead at World Economic Forum. Jean-Pierre Raymond is Head of Innovation Partnerships. Jens Wiegen, a Senior Scientific Information Officer at CERN. Nikki Böchler, Director of OpenData.ch. And Rachel Ainsworth, Research Software Community Manager at Software Sustainability Institute. Dear judges, we are very thankful to all of you for being with us, for joining us, and for taking your time to join this year's Webfest, this special edition, the first Global CERN Webfest. Thank you so much, and a very good luck to you with evaluating the projects. It will be probably a hard choice, considering that we have so many great challenges, so many great ideas, but we are sure that they are in good hands, in your hands, and we are very excited about the outcome. So just to summarize, we have 12 judges with a range of skills and backgrounds, and who are representing different organizations, which we are very excited about and honored. And speaking about evaluation and judges, we would like to remind you again about the evaluation criteria. So as mentioned before, we have three main criteria based on which your projects will be evaluated. So these are innovation, presentation, and impact. They will be evaluated on a scale from 1 till 5, while 1 being the lowest point and 5 is the highest. So our judges will first of all take into account in how far innovative is the technical solution you propose, in how far creative was your video presentation, which I think all of you did quite well and a great job. And another criterion is impact. What is the potential impact of real-world applications of your projects? So these are the main criteria, the main points that our judges will take into consideration while evaluating your job, what you have managed to do over the weekend.
Great, thanks for that nice recap there, Anastasiia. Perhaps now, if it's possible, we would like to just go over our program timeline with you all one final time. So, starting from where we are now, which is the end of the hack session, this evening we do have some more events coming up for you. A little bit of fun, starting at 8 p.m. Central European time. Perhaps you could tell everyone about that, Anastasiia?
Yes, so we have a great relaxation coming for you, waiting for you after the long weekend. You obviously deserve it. We have a music session provided by DJ Collective Sonntagsstift, starting again today at 8 p.m. Central European Time. I strongly encourage you to join the session. As mentioned before, you deserve it. Please join, take this break, take this breath, and have fun. You deserve it.
And then I'm pleased to let you all know that our how-to workshops are not over. We have one last one scheduled for tomorrow. So at 4 p.m. Central European Summer Time, we have a special workshop on how to proceed with your projects. You know, you've all done excellent work over the weekend, invested your time and energy and your creativity into these projects, and it's been fantastic to see that. And it is such a shame with hackathon events like this when that gets lost. So we encourage you to come along to this workshop, or if you can't watch it live, as with all other workshops, it will be available on our YouTube channel to watch later if it doesn't fit for you on Monday at 4 p.m. CST. So please do take a look at that and have a think, both by yourself and together with your project colleagues, about how you might be able to take your work from this weekend further.
And after that, tomorrow, Monday at 5 p.m., we are going to have a very important webcast, a very important session that I know a lot of you are waiting the most on. It will be a voting ceremony and closing ceremony of CERN Webfest 2020. It's really hard to believe that it's almost over, but we are very happy, and we'll be happy to see you all joining us tomorrow at 5 p.m., where we will present you the 5 shortlisted highlights, and we'll also announce the winner from those 5 highlights. So please make sure you join us. You won't regret.
Yes, so please do join us at 5 p.m. CST tomorrow. You can see this again on your screen now. And then just one last reminder that for any of the workshop sessions that you've missed, or indeed any of these main sessions, you can find them all on our YouTube channel. So thank you very much indeed. I don't think there's anything left for us to say now, other than to express our thanks to each and every one of you, to hope that you join us at the DJ session at 8 o'clock. And of course, we hope to see as many of you as possible back tomorrow. But before we go, we would just like to tell you about another hackathon coming up, which may be of interest to you all. So for that, I'd like to hand over to our colleague, Karolos. Hi, Karolos.
Hello, Andrew. Hello, everyone. Very nice to be here again, talking to all of you. So yes, indeed, we are moving from hackathons to hackathons. So at the Port, which is an association we started a couple years back in 2014 with several physicists from CERN and other people, we've been organizing what we call humanitarian hackathons, which basically roam around solving humanitarian problems during hackathons. It's very similar to the Webfest this year because we're going to do it online as well. So it's going to be very similar to the Webfest, and we have to prepare a lot to do everything online. But we've got some experience with this because a few months ago, we organized the Big versus Virus hackathon, which had 4,000 participants and was very big around Switzerland. This Webfest was a bit smaller, but still had a few hundred participants. And for the Port Humanitarian Hackathon, which happens in October, we actually expect about 100 participants in various teams. This case, the challenges will be tackled a bit differently. So we have a lot of partner organizations, for example, the Red Cross, Terre des Hommes, Médecins Sans Frontières, and several others who actually collaborate with us with coming up with challenges that correspond to real needs on the field. So you'd be working directly to problems that are a real world problem, which really has an entity in need for a solution. So with that, we're actually pushing towards having whatever is developed during the hackathon in 48 hours to be brought to the field as soon as possible. And so we'd be very excited if you are willing to apply for this hackathon, and you could find the Indico link there, or you could visit us on theport.ch for more information, or reach out on Slack or Mattermost, sorry, if you're on the channels.
Thank you so much, Carlos. We encourage you all, indeed, dear participants, to join in as a hackathon. After working with the GlueNet team that Carlos represents, is one of the representatives, I can assure you it will be a great event worth visiting, so please make sure you do join. And I would also like to take this opportunity to thank our all partners who made this event happen. We are going to mention them, of course, also tomorrow after during the closing session, but it's just nice to give you an overview of all the partners that we've been working on. Our special thanks goes to, of course, GlueNet team and Remotely Green, the co-organizers of the event that have been supporting us so greatly, especially in regard to the technical support. A very big thank you to all of you. You did a great job. We would also like to thank Fitness Club, CERN, and support. You were great. Thank you so much for agreeing to help us to provide the workshops, to provide you help and support. Without you, everything wouldn't have happened. And we are very glad to receive such positive feedback from our participants. That's also very much thanks to you. So please check on our website all the partners that you've just seen on the presentation slide. You are also able to see them on our website. Thank you very much again to everyone. And we do hope to see you soon at our music session with a DJ to have some fun, have some rest. And we are really looking forward to see you all tomorrow at the closing session and awarding session.
So thank you from all of the team. Look forward to seeing you tomorrow, and look forward to seeing as many of you as possible as well in the music session starting at 8 p.m. Central European Summer Time this evening. Goodbye, everyone.
Goodbye.